Hi guys, so in this video I'm going to show you one example of using long division to divide, and then I'm going to show you two examples using synthetic division. We tend to use synthetic division if we can, but I'll show you in the next video or in the next slide why it doesn't always work. So it is good to be able to do long division as well. If you forget how to divide just do long division on regular numbers, that's something you may want to just do out really quick, because the actual algorithm, the process, is exactly the same as we would do for regular numbers. Okay, so I wrote it out the same way I would if I was, dividing like a 2-digit number by a 3-digit, and I am going to start by the same way I would start if I was doing other division. So I'm going to say, I'm looking at this x right here, and I'm saying how many times does x go into 2x to the third? Okay, and it goes in 2x to the second times, if I were to divide those. Okay, and then I'm doing just like I would if I was just dividing regular numbers. Then I multiply the 2x to the second by the x, and I get 2x to the third. And then I also multiply that to that number right there, the 2x to the second times the minus 3, and I get a minus 6x squared. So if I'm doing this right, all my terms should be like, all the terms that are lining up on top of each other should be like terms. Okay, so next, when I do long division, I subtract these two expressions. So what I'm going to do is I'm subtracting, which makes this addition. I'm really changing all the signs of those. So this should always drop out, and now I end up with 3x to the second. And just like with regular numbers, I bring down my next term, and then I do the same process again. So now I'm looking at, okay, how many times is this x? I don't worry about the 3. The 3 I'm just using when I distribute. I'm saying how many times does x go into 3x to the second? Okay, and that goes in a positive, you do want a sign in between there, a positive 3x times. And then I'm bringing this 3x, I'm going to distribute it to this, and then also to the minus 3. So I end up getting 3x to the second minus 9x. Okay, and I'm going to do the same thing. I'm going to subtract, which makes that addition. Just as changing all the signs. And then these drop out just like they should, and I get a minus 2x. Keep going till I have no more terms to bring down. And now x goes into minus 2x minus 2 times. And then I distribute, so I get minus 2x plus 6. I subtract, which makes this addition, this subtraction. Those drop out, and I get a 1. Okay, so this has a remainder of 1. Okay, so what that means is when I divide, 2x to the third minus 3x squared minus 11x plus 7 divided by x minus 3, I end up with a remainder of 1. So there's a couple ways you can write your answer. Let me show, oops. Yeah, I'm just going to move that up for a second. Let me show you one way. So we would say that f of x, this function is equal to, I just want to be able to see both of those. Sorry about that. That function is equal to x minus 3 times 2x to the second, that's my quotient, plus 3x minus 2, and then plus remainder of 1. Okay, there's multiple ways to write it. You're going to see MyStatLab sometimes going to ask it like that. Sometimes it's going to have you put the 1 over the x minus 3 the same way you do with the remainder when you write it with just regular numbers. Okay, so let's look at an example now. Okay, so I'm taking the same example. I'm going to use synthetic. The idea is with synthetic divisions, it only works when this piece that I'm dividing by right here has to be a binomial with a leading coefficient of 1. Okay, so I have before that x is a 1, so this is a perfect example of when synthetic division works. But if that were something like 2x minus 3, I couldn't use synthetic division. All right, synthetic division is nice and fast, so this is what you do. Okay, the idea is when I'm dividing by x minus 3, I'm actually checking, I'm really actually testing to see if 3 is a root. Because if I have x minus 3 equals 0, then x equals 3. Okay, so if x minus 3 really goes into this polynomial, then I know 3 is a root. And that's why my next step, when I set this up, a 3 goes on the outside, not a minus 3. Because that's the root I'm actually testing. Okay, and all goes in here is just the coefficients. So I have a 2 minus 3. These are coefficients of the thing the polynomial I'm dividing into. Sign and all. If there were anything missing, this one has a cubic, then a square, then a linear, then a constant. If anything were missing in there, I would fill in a 0. All right, so this is kind of fast, so just kind of watch this. The first thing I do is I bring down the 2. I draw a line here, I bring down my 2. Okay, so I take and I multiply the 3 and the 2 to get 6, and I put it here, and then I add. Okay, so each time I really multiply, and then add. Okay, so I multiplied, then I add down. Then I multiply these, and I add down. And then I multiply, and I add down. And if you look at it, that's the same remainder I got before. So that means that this whole thing is equal to x minus 3. That was what I divided by. This part right here, let me circle it, gives me the coefficients of my quotient. So that means it's a 2x to the second plus 3x minus 2. And if we look at that, it was the exact same quotient we got for the other one. And then we have this plus 1 as a remainder. So when I have my quotient, if the beginning polynomial that I was dividing into had an x to the third, my quotient always starts 1 less. So that's how I knew that the 2 was attached to an x squared and not x to the third, because I should be dropping down a power of x. Okay, so I wanted to try one where it did go in evenly. Okay, so in this example, we're going to take this polynomial, x to the third minus 2x squared minus x plus 2, and we're going to divide by x plus 1. So keep in mind that if I'm dividing by x plus 1, it really means I'm trying to see, I'm testing the value x equals negative 1. If x plus 1 goes in evenly, I know x equals negative 1 is a solution, is a root to this. So that's why I'm going to put negative 1 out here. I'm going to put my coefficients here inside. Okay, I'm going to bring down my 1. I'm going to multiply. I'm going to add. Then I'm going to multiply, add down, multiply, add down. Okay, so I have a remainder of 0, which means it goes in evenly. Okay, so it means that that original polynomial can be written as, let me move this up a little bit here. That original one, this x to the third minus 2x squared minus x plus 2, I'm going to start writing in factored form as, okay, x plus 1 went in evenly, and the result, what I get from here, is x to the second minus 3x plus 2. Okay, so it helped me start getting it into factored form. So I know x minus negative 1, x equals negative 1 is one solution. So now, usually when you do synthetic division, you can now keep finding the rest of the roots by keep breaking down whatever you have left. So this thing right here, this polynomial that's left there, is factorable. If it's not factorable, then if I had to find the solutions, then I would have to rely on using the quadratic formula. But that one, if I want to keep factoring, it would be x minus 2, x minus 1. So now I can see, if I were trying to find the solutions, for right now I was just dividing it, but I can see that x equals negative 1, x equals 2, and x equals 1 are solutions. So that's what we're going to start to do in the next video. But for now, we were just trying to actually divide this.